Welcome to the review video for Unit 6 for Algebra 2. Since we don't have a review sheet for this unit, I'm just going to go through and pick problems from homeworks 1, 2, 3, and 4. And you guys have these already. You have the keys. So you're going to be using this then as your study guide. So I'm just going to go in the right order. So starting with homework 1, does that make sense? Starting at the top here, I have to decide if each relation is a function. So when we're talking about something being a function, that means it passes what we call the vertical line test. This also means that every x has only one y. So when we look at A, we should look at this and say, well, this is an x squared, so this means it's going to be a parabola. So a parabola is a function, and this is going to be a sad face parabola because the leading coefficient is negative. So it would look something like that. And this would, in fact, pass the vertical line test. No matter where I, draw a vertical line, it's only going to hit the parabola once. So if I actually get a picture of what this looks like, I can then discuss what the domain and range would be. So I just have my calculator over here. Here's the equation. I'm going to do a zoom 6 for the graph. Okay, so there's my parabola, and like I said, if I do a vertical line, it's only going to be hitting the parabola once, so it passes. The domain of a parabola is going to be from left to right. Are all my x's being counted for on the parabola? Yeah, this guy, as I'm moving to the left, the function is approaching negative infinity. As I'm going to the right, the function is approaching positive infinity. So the domain is all reals. Every x value is being used. If I look at the y's though, you see I have a maximum value here. So this value is occurring at what looks like 4, but if I want I can just double check. So second trace. Okay, so my maximum point here is y equals 4, and the function is going down. Its end behavior is going negatively, so my range is going to be from negative infinity to 4 with a closed bracket because I'm including 4 in the y values. Say I look at something like c though. If I'm looking at this, it's a set of points. It's not a line, or any other function, or as far as a parabola. It's just a set of points. Is this a function? So you have to ask yourself, are any of the x's repeating? Does every x have its own y? 3 has 0, 2 has 1, 4 has negative 4. No x's are repeating, so yes, it's a function. So since it's a function, the domain would be just the x values. So 3, 2, and 4. The range would be the y values, 0, 1, and negative 4. Okay, now if we look down at f, when you see an x being squared and a y being squared, that should be your key to know that this is a circle. And specifically, this is a circle at center 8, negative 1 with a radius of 7. But all you really need to know is this is a circle and it does not pass the vertical line test. It is being hit twice. So this is a no. So say, for example, then I want you to graph a piecewise function. So it's made up of different pieces of other functions. So like the second example on the back page of homework 6.1, and then we would talk about the domain and range of it. It's made up of a line, a square root function, and another line. And it's along certain intervals. So what we talked about in class is how we're going to set up 3 different tables to help us graph. That's going to be showing our work. Then we use it to graph. So if I pull up my calculator, what I've done is, in the order that they're presented, I have inserted the functions. So the line, the square root function, and the second line for y1, y2, and y3. I'm going to look at my table of values, and this is where I'm going to pull all the information to set up my tables. Now, looking at the first function that I'm given, so I'm just going to put this calculator away for a second. I need to look at the line when x is less than -5. So something that might be helpful for you guys is just to write out a number line. So if this is -5, keep in mind that less than -5 is -6, -7, and so forth. And greater is -4, -3, all towards 0. Okay, just to give yourself some number sense, because sometimes looking at the table can be confusing. Okay, so setting up my first XY table. Because I'm interested in values that are less than -5, that means from the table I'm going to pull up values like -5, -6, and -7. Those are values of x less than -5. So pulling up my calculator, it looks like -5 is -7. And -6 is -9. And -7 is -11. Okay, moving on to my square root function. Oh, and actually before I move on, if I'm looking at when x is less than -5, at this point, since it is just less than, it is going to be an open circle at that point. Okay, so then for the second, the square root function, I need to be between -5 and 1. So -5. Okay, so I'm going to go to my table. I'm looking at y2, and you'll notice some errors as we talked about in class, because if we put, -7 underneath the square root sign, the radical underneath would be negative, and the calculator is not going to graph an imaginary number. Okay, so at -5, it is -2, and -4 is -1. I'm going to skip over some of the decimals because I'm just trying to get a graph here. -1 is at 0. 0 is a decimal, and 1 is a decimal as well. However, I need this point because of this interval, so I'm going to say this is about 0.45. Just because I need that to plot. Okay, before I move on, looking at -5, -2. If I look at the interval here, because this is x is greater than or equal to -5, this is going to be a closed circle. And at 1.5, because this is x is less than 1, it's going to be an open circle. So it's not including that point. Okay, and then lastly, I got to look at my y3. So I am going for values that are greater than or equal to 1. So like 1, 2, and 3 should be good. I'm just going to write out my table here. So 1, 2, 3. At 1, I'm at -0.5, -1, and -1.5. Okay, and just looking at x equals 1, because x is greater than or equal to 1, this is going to be then a closed circle. From here, all I have to do is graph. So to save some time on this video, I didn't show my whole graphing and everything, but I labeled my x and y axis. I have an open circle at -5, -7, like I said I would. I'm closed at -5, -2. Open again at 1.45, and then closed at 1, -0.5. And notice that I am drawing some lines, or in this case they're actually rays, where the arrows are pointing to show that it's extending. So then to talk about domain and range, if I'm looking from left to right, so looking at my axis for my domain, even though it's open here, it's closed here. Even though it's open here, it's closed here. So looking from left to right, every single x value is accounted for. So my domain is all reals. The range, however, looks like my high point here is at 0.45 approximately, and it's going down toward negative infinity. So in order to write this, I have it from the low value, so negative infinity to 0.45, and that'll be open as well, or an open bracket or a soft bracket, because it's an open circle at 0.45. Alright, so now I'm going to move on to homework number 2. Top of 6.2, I'm going to give you a piecewise function and you need to write the equation of it. So if I'm looking at this function, I'm going to start with just the domain and range. Looking at this function, it's extending out towards infinity if I'm looking to the right and toward negative infinity to the left. The only value it's not going to be, though, is x equals negative 1. So the range, or the domain, excuse me, is going to be all reals, but it cannot equal negative 1. The range, based on the end behavior, it's going up toward positive infinity, but its low point is down here at 2. So the range is from 2, including 2, to infinity. Alright, so now I'm going to write the equation of this piecewise function and recognize that it's made up of 3 lines. 1, 2, 3. In order to come up with the equation of a line, I need the slope and the y-intercept. Slope is equal to rise over run. So since I am going in the first line down 2 over 2 or down 1 over 1, my slope is negative 1. The y-intercept, if I continued this line, would hit at negative 3. Oops, all right, so putting it together, the equation of this line would be y is equal to negative x minus 3. The one in the middle is a horizontal line at y is equal to 2. And lastly, I need to find the slope and the y-intercept of this line. So the slope looks like rise 1 over 1. The slope looks like 1. And the y-intercept, if I were to continue this going the opposite direction, it would also hit at negative 3. So this would be y is equal to x minus 3. So now I got to put it all together. So f of x is equal to, so starting from left to right, I'm going to be this line first. So this is the equation. This is going to be the y is equal to negative x minus 3. And it's going to be this line when x is less than, because it's going toward negative infinity, x is less than negative 1, but not including negative 1 because it's an open circle. Next, I'm going to be the line y equals 3. And that's running along the x-axis from negative 1, but not including it, to 1. Just like so, but it is including 1 because this is closed here. And then lastly, the function is going to be this line. So x minus 3, and that's happening when x is greater than or equal to 1 as well. And that's the equation of your piecewise function. All right, I could ask you a question given a function g, so here's a picture of it. I want you to find each of the following. When it says g of a number, f of a number, h of a number, whatever, this number inside the parenthesis is an x value. So what it's saying is go to negative 2 on the x-axis, so here's negative 2, and tell me what the corresponding y value is. Here it is. Looks like it's at 1, so g of negative 2 is 1. Just like that. So g of negative 4 would be over here, and I would get 1 again. It's the same exact thing for 1.5, so like 1.5, I'm at 0. And I didn't plan to do these, but they're so quick. And then g of 4, 1, 2, 3, 4, down here. So this looks like, oh wait, 1, 2, 3, 4. Yeah, I did that right. Okay, so this looks like it's at 2.5. Or negative 2.5, excuse me. When it says x if g of x equals 1, keep in mind that g of x is a fancy way of saying y. So when y is equal to 1, that's a horizontal line. Oops. Come on. Going through 1. So something like that. So when y equals 1, what are the x values? I see 3. Oops. 1, 2, 3. So just naming those, x is equal to, looks like negative 4, negative 2, and 1. Same thing for if g of x equals 3, so g of x equals 3, so y equals 3. Looks like it's 1 point, and that's going to be x is equal to 0. Okay, I could ask you to evaluate a function at an x value, and you just plug it in for x and find out what the corresponding y value is. So in something like a piecewise function, though, when you're evaluating it at a particular x value, you have to decide where it falls in these intervals to decide which piece of the piecewise function you plug it into. So if I'm evaluating it at x equals negative 3, you have to decide where does negative 3 fall. In x is less than or equal to negative 5, or x is greater than or equal to negative 5. Well, negative 3 is greater than negative 5, so I'm going to be plugging it into the second function. So h of negative 3 is equal to negative 3 cubed plus 7. So that is negative 27 plus 7, so negative 20. Okay, on the test we could also ask you for what the average rate of change is, and remember, average rate of change is really just a slope. So that's your change in y over change in x, or rise over run, difference in y's over difference in x's, and so forth. So we're going to give you a specific interval, so say like 0, 3. You're going to go on the graph here and say at x equals 0, y is equal to 1. So this is the point 0, 1. At x equals 3, it looks like I am at 9, or wait, not 9, 7. Please, come on. And then I'm just going to calculate the slope between these 2 points. So 7 minus 1 over 3 minus 0. So 6 divided by 3. So the average rate of change is 2. Working with compositions of functions. So I have 3 here, f of x, g of x, and h of x. And just going through quickly what each of these means. So like g plus h of 8 is the same thing as g of 8 plus h of 8. This is the same thing as h of 4 times f of 4. H of 17 minus g of 17. And lastly, g of 11 divided by f of 11. So by rewriting it like this, you guys know how to evaluate each function separately at a certain point. Then you just combine them. So like for the first one, if I'm looking at g of 8, I'm going to look at my g function and say this is 8 plus 1 over 3. So 9 divided by 3 is 3. Plus my h function, I have 3 times 8 plus 1. So that's 24 plus 1, which is 25. So my answer is 28. If I look at d, okay, so g of 11, g function 11 plus 1 divided by 3, all divided by, looking at the f function, the square root of 11, oops, sorry, 20 minus 11, 20 minus 11. Okay, clean it up. So this is going to be 12 divided by 3, which is 4. And this is going to be the square root of 9. So this is just 4 over 3. I could ask you the domain of each of the following functions and then ask you to do composition work with them as well. So starting with f of x, 1 minus 2x is just a line. And we know a line has a domain of all reals. This is a square root function. What it looks like is a square root function that's been shifted to the left 4 units. So if I'm talking about the domain, it's going from -4 to infinity. Okay, for h of x, I just need to make sure that this guy doesn't go to 0. So x cannot equal -3, otherwise the domain is all the rest of the real values. And lastly, the cube root function. This has been shifted down 1 unit. So it looks something like that. The domain is going to be all reals again. It's going to go to negative infinity. It's going to go to positive infinity. It's just going to take a long time. And by that I mean going out this way and out that way. Okay, so then I could ask you to do composition work with them and state the domain of the new functions. So if I have f of g of x, or f times g of x, this is f of x times g of x. So f of x is 1 minus 2x. G of x is the square root of x plus 4. So in order to multiply these, I'm just going to distribute the square root. So I've got x plus 4 minus 2x times the square root of x plus 4. And that's what f times g of x looks like, or f of x times g of x. So when I'm talking about the domain, I'm going to look at the domain of the original functions. So f was all reals, g of x is from -4 to infinity. So the domain must be from -4 to infinity. Okay, but then look at k of x divided by f of x. I am going to do the division. So k of x is x cubed minus 1 divided by, okay, f of x is 1 minus 2x. When I look at this, it's now a fraction. I'm going to look at the denominator and say, what can x not equal? Well, 1 minus 2x equal to 0. This is 1 is equal to 2x. So x equals 1/2. This is what's going to cause my denominator to go, or my entire function here to go undefined. So I'm going to say that the domain is x cannot equal 1/2. Notice that the domain changed from what the original ones were. I don't have x does not equal 1/2 for any of these domains. So I had to recalculate what the domain would be of k of x divided by f of x. Okay, so when I move down then, I could ask you to look at two functions and tell me what is h of p of 2. So you're going to do p of 2 first. So you read it backwards. So evaluate p of 2. So you have 2 times 2 minus 3. So 4 minus 3 is 1. Then I'm going to take 1 and plug it into h. So h of 1 must equal 1 squared, which is 1. Now note that this notation is the same thing as saying p of h of 7. Whoops, I don't want it written that way. I want p of h of 7. Okay, that looks better. So these are the same thing. It's still read backwards though. All right, so then at number 4, what if I just want you to evaluate it at x? Well, g of x then is going to be plugged into f of x. So to write it differently, It's like this. So f of x is equal to x squared minus 4. So now in f, where I have an x, I'm going to substitute in g of x, which is x minus 5. So I have x minus 5 squared minus 4. So this is x squared minus 10x plus 25 plus 4. So x squared minus 10x plus 29. If I do g of f of x, then it's going to be f plugged into g. So g is x minus 5. So g of f of x. I'm plugging in now, so going the other way, I'm taking x squared minus 4 and plugging it in for x. So just to clean it up, I have x squared minus 9. Okay, so looking at the composition notation at C, I could ask you, what is g of f of 3? So f of 3, I'm going to go to my graph. F of 3, careful, it's a g function. F of 3 is up here on my f function. This is my g. So it looks like I am at 1.5. So then I'm looking for g of 1.5. So 1.5 is about here. Go up. And I'm ending up at 4.5. Okay, for D, g of 3. So go to 3. Go up to the g function, which is the navy blue one. So I'm at 0. So then I'm doing f of 0. So f of 0 then, here is 0, and I'm at 0 again. Okay, so now look at f. The notation here is f of 1 times g of 1. So if I look at my graph, if I go to 1, go up to the g function, it's going to be 4. And if I look at the f function, I'm at 0.5, or 1/2. 1/2 times 4 is 2.